Hello everyone, myself Kaleshwari, Assistant Professor, Department of Electronics Engineering, SNS College of Technology, Coimbatore. Today we are going to see about the topic half adder from the Unit 2 Combinational Circuits and the subject of design of digital circuits. So, uh, adder is nothing but it is a logical circuit in digital electronics. It is mainly used for the addition of numbers. So before going to the adder, we are all know about the what is meant by combinational circuit. So combinational circuit is nothing but the output of any time depends only on the input values at that time. So in your, for example, we take it as a digital computers and calculators, which is consist of arithmetic and logical circuits, right? So which contain logic gates and flip-flops that is very mainly used for the addition, subtraction, multiplication, and division of the binary numbers. So in this, the basic building blocks of this arithmetic unit is unit in a digital computers are adders. So these circuits perform the operations at speed less than 1 microseconds. So for this, we have the two types of digital systems like combinational logic circuit and then sequential logic circuit. So in this combinational logic circuits only, we are having the half adders, full adders, or like that. So okay, what is meant by sequential logic circuit? So which is also having the output at any time depends on the present input and also having the past output values. So for example, we take it as a counters or the sequential circuit. Okay, so in this design of combination circuit, we have some set of procedures. So first we have to identify the inputs and outputs for the respective uh, topics. Like for half adder means what is the input output, and full adder what is the input output likewise, and then draw the block diagram based on this input output and draw the truth table, and then after the truth table, we have to write down the switching expression for that output. So this switching expression can be simplified by using the K-map method. And finally, we have to implement the simplified expression using logic gates. So this is about the procedure for the combination logic circuit. Okay. So this is half adder. Half adder circuit has two types of inputs, that is one is A, another one B. These are the called as two variables, uh, and which is add two input digits and generates a two output, that is sum and carry. It mentioned as SNC in the figure. It adds two binary digits where the input bits are termed as organ and addend, which is result to be as the sum and carry. It performs the sum operation, and then it gives the XOR is applied with the both inputs, and AND gate for applied for the produce the carry. So this is the block diagram representation of this half adder. And another one is truth table. This is the truth table for half adder based on the input output. The input is two, that is A and B. For this two variable or two input, we have four number of combinations like 0, 0, A0 and B0, and then 0, 1, and 1, 0, and then 1, 1. So for the input A0 and B also 0, the sum value is 0. That means 0 plus 0 is equal to 0. There is no carry in this by adding these inputs, and then 0 plus 1, the sum value is 1, there is no carry here, and 1 plus 0, here also the sum value is 1, there is no carry, that's why I'm putting 0. And finally 1 1, right? So for this 1 1, we have the 1 plus 1 value is equal to 10, right? So for this 10, we have put the 0 in sum value, 1 in the carry value. Okay, so this is about the truth table of half adders. So for this truth table, by using this truth table, we can simplify the switching expression by using the K-map method. So for this sum, we are using K-map, and then for this carry, here we are using the K-map also. It having only two variables, that's why we are selecting the four cell combination of this pictorial representation. Like sum value is 0 1 1 0, here 0 1 2 3. Okay, 0, 1, 1, 0. So this is the representation. So there is no possibility for the pairing of this function. So here A, and then here is a B, like A B bar and then A bar B. It's a function of XOR gate, like A XOR B. So the sum value is A XOR B. Okay. So next one for carry. So in this carry, we have only one in the third cell. So here this separated here. So by seeing the row and then by seeing the column, it is A and B. So carry is equal to AB. Okay, so this is about the truth table, and based on the truth table, we have derived the game of simplification. The final answer for the sum and carry is sum is A XOR B and carry is AB. So this is the logic diagram for this function. AB XOR, it is called sum. A and B using the AND gate, we are having the carry. So, where it is used, that is the half adder where it is used means the half adder and also the full adder of both are used in the ALU, that is Arithmetic Logic Unit of computer processor to add function binary bits. Half and full adders are used in calculators also in your arithmetic function. So half adder is used to realize the full adder circuit. That is, two half adders can combine to give a full adder circuit. Half adder is used to calculate the addresses and table functions. So this is the main applications of half adder. These are all the reference. We can take the material. Thank you.